Hey Pre-Calculus, we're in section 7.5. We're going to be solving trigonometric equations. So our notes and vocabulary really just consist of that concept of principal values. When we're solving trigonometric equations that have sine, cosine, tangent, there are some values that we are going to be looking for because, these are periodic functions. They go on infinitely. So the principal values kind of restricts the domain or the values of theta that we're actually looking for when we solve them. So for sine of theta and tangent of theta, theta will be in either quadrants 1 or quadrant 4. Not either. We'll look for answers that are in quadrant 1 and quadrant 4. And then when we're talking about the cosine of theta, theta will be either in quadrant 1 or quadrant 2. Notice these quadrants are adjacent. So this is where the principal values are found for each of the trigonometric functions. So let's go ahead and get started looking at some of these examples. So here in example 1, we're going to solve this particular situation for the principal values of x. And so here's what we need to do. We need to start off with this equation and kind of see what we can do algebraically. Now, guys, I'm a fan of S and C for the sine of x and the cosine of x, using it as kind of abbreviations. So sometimes that can be helpful. And so we're going to do that now. So sine times cosine minus 1/2 the cosine is equal to 0. If this were an algebra problem, we totally would factor out the c. And so we'd have s minus 1/2 is equal to 0. So now that we have this, if this again were an algebra problem, we would recognize this to be a cosine, or c could equal 0. And s minus 1/2 could equal 0, right? Because we know if two factors multiply to give us 0, then one of those factors or both of those factors has to be 0, right? One or both. All right. So cosine of x is equal to theta, and the sine of x minus 1/2 is equal to 0. I said theta, that should be 0 over there. Sorry, I'm so anxious to solve for x and the angle I'm talking about, theta. So sine of x minus 1/2 is equal to 0, which means that the sine of x is equal to 1/2. So now the question is, using these to figure out what x must be, we need to keep in mind that we're considering the quadrants that we're looking in. So I'm going to draw a quick xy axis, pair of axes here, and kind of think it through. So when is cosine 0? Do you guys remember? Remember, cosine has to be in quadrants 1 or 2. Is cosine 0 in either quadrant 1 or quadrant 2? Well, between quadrant 1 and quadrant 2, cosine is 0 when, let's get this out of the way, cosine is 0 when x is equal to pi over 2, right? Yeah. All right, I hope that makes sense. So pi over 2 gives me the cosine of 0. So one answer is that x could be equal to pi over 2. And the other answer is going to come, or other answers, let's see, may come from this situation. So when is the sine of x in the first quadrant or the fourth quadrant? When is the sine of x equal to a positive 1/2? Well, sine of x is only positive in the first quadrant, not the fourth. So really we're only concerned here, and sine of x is equal to 1/2 when x is equal to pi over 6. So let me highlight that up here. X can be equal to either pi over 2 or pi over 6, and that's how we do it. All right, now highlight there so you can keep your eye on the answer. All right, let's go ahead and try the next one. Okay, so this one we're going to have fun with. Let's go ahead and take a look at our situation here. First of all, we have another equation that is requiring us to consider sine and cosine. And we also have a different restriction. Instead of being asked to use the principal values, we are asked to solve for x such that x is somewhere between 0 and 2 pi. So let's get started. All right, I like to do. So c squared minus c plus 1 equals s squared. And as I'm looking at this, I'm noticing that all of this is in terms of c over here, and it's always good to have equations in terms of one variables. You know this. It's never good to do this. Is there some way that I can change this s squared into, or this sine squared into cosine. And then I remember that s squared plus cosine squared is equal to sine squared. Sine squared plus cosine squared equals 1 rather. And that's the Pythagorean identity. So what I'm thinking I'm going to do is to substitute s squared for 1 minus c squared. So now everything is in terms of cosine. So c squared minus c plus 1 is equal to, let me make a plus sign, 1 minus c squared. Okay, this is looking good. Let me bring everything over to one side and see how that works, because this is looking like a mad quadratic equation, right? So if I move this over here, I get 2c squared minus c, and when I move this over, oh, just minus c. The ones cancel out, boom, boom. So that's equal to 0. Okay, this is easy. C 2c minus 1, you guys saw me factor out that c, and we're still dealing with a similar situation as before. What this is telling me is that each of these factors must equal 0, and therefore the cosine of x is equal to 0. Well, we already dealt with that. Let's see if we can figure out how that works out again, now that we're dealing with a different domain where we're looking for our answer. So the cosine of x is equal to 0, and then 2 times the cosine of x minus 1 is equal to 0. And what this amounts to, when I move the 1 over to the other side, divide both sides by 2, I get that the cosine of x could also equal a positive 1/2. And so box those so I can keep in mind where my answers are coming from. Remember, x is going to be somewhere between 0 and 2 pi. So we need to look at all the quadrants here, right? So I'm drawing this more for my own mental self than for you guys needing this help. But cosine of x is 0. We know that happens here, and we know that happens here. So that happens at pi over 2. And then that's going to happen again down here at 3 pi over 2, right? So that's the two answers we get here, pi over 2 and 3 pi over 2. And what else do we have going on here? Let's see what's going on. When is the cosine a positive 1/2? Well, cosine is positive in quadrant 1 and in quadrant 4. And we know that we get this 1 over 2 value when we're dealing with the 60-degree angle or the pi over 3 angle. So if we've got pi over 3 up here, this would be, what would this be? Negative pi over 3, which is, well, let me go ahead and think about that. So we know pi over 3 is an answer. That's 60 degrees, and that's when cosine is that value. And negative 60 degrees would be 300. You guys see me trying. So that's 2 pi over, 2 pi minus pi over 3 is what I'm thinking about. I'm just going to let you guys see me work it out. 6 pi over 3, which is 5 pi over 3. If you got it before me, you should just tell me how good you are, because I struggled. All right, so this is, these are rather the 4 answers, or the 4 possible values of x from this problem. Thank you guys for your patience. I'm going to highlight that, and we're going to move on to the next one. Okay, here in example 3, we're not dealing with sine or cosine this time. We're dealing with secant squared and tangent to the 4th power of x. So we want all real values of this. So this is a different restriction for us. We need to think about what that means. How do you write all the values? You know, we're dealing with a periodic function, and you know there might be like many values. So let's think about how we'll do that as we work through this problem. Now, first of all, secant squared, this is reminding me of something that I think we knew, but maybe have forgotten. Do you guys remember this identity? Do you guys remember how we were dealing with the Pythagorean relationships, and one of them was 1 tangent squared theta plus secant squared theta? And the benefit of changing this to a tangent expression is so we can have everything in terms of tangents. And then maybe I can just play around and be like, you know, 2 times 1 plus t squared minus t to the 4th power. You guys see what I'm doing? I'm saying that the tangent of x is equal to t, and I'm substituting here. Yeah, you know, I like playing with algebra. So then, now that we've changed this to a more all one variable or all one function, now we're going to see if we can kind of treat it like our algebra joy that we like to do. So I have 2 plus 2t squared minus t to the 4th power equals -1. And as I'm looking at this, I'm like, man, this looks like a quadratic in disguise. You see how like this has the fourth power, the second power, and then like 0 power. It has that vibe. So what I'm going to do is make this convenient for me. I'm going to move everything over to the right. So I'm dealing with a positive t to the fourth power minus 2t squared. You guys see me? And then I'm moving this over and I have a -3. Now my question is this thing factorable? Let's see what we can do. So as it is kind of a quadratic like, I'm going to try to factor it like I do regular quadratics that are factorable, right? So let's see, -3 can be created by a -3 and a +1. And I think that'll do it. I think that does do it. So look at that. We end up having a properly factored situation. Now the question is, can we solve the rest of it? Okay, we can. So each of these requires that we set each of these factors equal to 0. So this means that the tangent squared theta, or x, I think we were using, let me stay consistent. Tangent squared x is equal to -1, and tangent squared x could also be equal to 3, right? And so if that's the case, if I take the square root, because tangent squared x is not actually a thing that I can deal with, so I got to take the square root of it. Tangent of x has to be equal to plus or minus the square root of -1. I don't know about you, but you know that -1 is I, plus or minus I is an imaginary number, but I've never seen tangents equal imaginary numbers, especially since we're dealing with a real number plane. So this is not going to lead us to a solution. Let's check on this one. Tangent of x is equal to plus or minus the square root of 3. Now I'm thinking, wait a minute, there was a time when tangent was equal to the square root of 3. It was when we were dealing with, if my memory serves correctly, when we were dealing with 60 degrees. So when we were dealing with 60 degrees or pi over 3, we know that the tangent is going to be the square root of 3. And in fact, the tangent is going to be the square root of 3 and plus or minus the square root of 3, because now we are using either sign in all 4 quadrants, any of the 60-degree angles in any of those 4 quadrants. So let me go ahead and draw a picture to help my mind, to help me figure this out. Okay, so here's my image, and we have pi over 3, 2 pi over 3, that's making that 60-degree angle, or that pi over 3 angle here, and then we get 4 pi over 3, and then 5 pi over 3. And so what I'm looking at here is, in terms of, let me scooch back up here, we want all real values of x. So I know if I could like write this down, I could say like pi over 3 and 2 pi over 3. And well, when I look at pi over 3, this movement from here to here to get this angle and this angle is going to be plus pi, right? So I could say pi over 3 plus pi, but I can do this over and over again because we want all of the values. So I can do plus k pi or n pi, I think I like n better, plus n pi, where n is an element of the integers. So we can do this all the time, like we can get all of these answers. So that's one set of answers, but then we have to think about this other set of answers over here, which comes from this situation. Now your text chose to talk about this as negative pi over 3, which makes sense. So your text had the answer negative pi over 3 plus, again, plus the series of pi's. So pi, let's say n pi over 3. I probably would have not thought about that and said 2 pi over 3 plus all possible values. Both answers are correct. It's fine. If you prefer the elegance or the kind of symmetry of the pi over 3, negative pi over 3, cool. If this is how you thought of it, cool. All of it is good. It makes sense because it covers all of the possible angles. Example 4 comes from the beginning of the chapter. When you ride a Ferris wheel that has a diameter of 40 meters and turns at a rate of 1.5 revolutions per minute, the height above the ground in meters of your seat after t minutes can be modeled by the equation h is equal to 21 minus 20 cosine 3 pi times t. How long after the ride starts will your seat first be 31 meters above the ground? So as with many of these problems, they offer us a bit of scientific information or a bit of physics information or whichever branch of science we're in. And then we are basically going to apply some of the concepts that we've learned today. So here's what we're going to start off with. Recognize that we're going to use this equation and then we're going to substitute in 31 where we want to solve for t. So let's place 31 in for the height, and we're going to try to solve for the cosine. We'll try to solve for t, but first let's solve for cosine of 3 pi times t. So when we move things over, we move the 21 over, we're left with 10 is equal to negative 20 times the cosine of this particular angle, and then we're going to divide both sides by negative 20 so that we get a negative 1/2, let me make that there, is equal to the cosine of this angle, cosine of 3 pi t. So here's the deal. We need to kind of think about what this means because we need to solve for this angle so we could eventually solve for this variable. So we know that the cosine is going to be negative in a couple of quadrants, and that's going to be the second and third. So we know that the cosine is, so we have a couple of answers is what I'm saying. So in the second quadrant, cosine is negative 1/2 when we're dealing with 2 pi over 3. That's that 60-degree angle. And then in the third quadrant, the angle we're going to deal with there is going to be 4 pi over 3. And so these are the two angle values that are possible values for 3 pi t. Are you with me? I hope this is making sense, guys. Okay, so 3 pi t. And so now this is going to give me the power. Let me scooch this over here. This is going to give me the power to solve for t. And so hopefully it makes sense that I'm going to factor out the pi's on both sides, so that goes away. Pi is really just a number. It feels like a variable sometimes, but it is a number, and I'm going to get t alone by dividing both sides by 3. So this is going to be 4/9. When I divide by 3, I'm multiplying by 1/3 is equal to t, and over here I'm going to get 2/9. Oh, I've said it's equal to 1/3. I don't know why I said that. And 2/9 is equal to t. Does that make sense? So we've got these two answers, but what we were asked for, let's scooch back up. What we were asked for is to find the time when the Ferris wheel, where your seat first will be 31 meters above ground. And the first or the earliest time is here 2/9 of a minute. And hopefully that made sense. All right, let's go ahead and look at our last example. Okay, so this final example is going to give us an opportunity to think about inequalities in reference to trigonometric functions. So we have 2 sine theta plus 1 is greater than 0, and our solution for theta needs to be between 0 and 2 pi. So what I will do is I won't even bother S&C'ing this up or whatever. I'm just going to say that we can see that the sine of theta is therefore going to be greater than negative 1 over 2. Hopefully that algebra was kind of a smooth move for you. And so sine of theta is greater than negative 1 over 2. Now we just need to figure out when is the sine of theta greater than negative 1 over 2 within the region of 0 to 2 pi, right? So if I'm thinking about 0 to 2 pi, let's use our unit circle and think about that together. Let's see if I can make a circle. All right, that's kind of okay. Let me try one more time. Let me try for a better circle. You guys are always patient with me and my inability to draw great circles. I thank you. All right, the computer corrected that nicely. All right, good. So if we're thinking about the unit circle and we're thinking about when sine is equal to negative 1/2, we know sine is positive in these two quadrants. Sine is equal to 1/2 when we're dealing with the angle that is related to the pi over 6 or the 30-degree angle. So we know that at this point here, where this would be pi over 6 more than pi is 7 pi over 6. And over here, I could talk about this as negative pi over 6, but since we're supposed to consider only values from 0 to 2 pi, I need to think about it in terms of a value from 0 to 2 pi, which is going to be 11 pi over 6. So pi less than 2 pi over 6, or 12 pi over 6, because that would be like 2 pi. All right, I'm walking my son. Okay, so what we know is that the values of sine are all going to be the y values along this axis. So we want sine of theta to be greater than -1/2, which it is at these points. Are y'all with me? So at these particular points, pause me and think about it, because I know it seems like we're dealing with a lot of stuff, but this point here and this point here, those are off limits, because that is where sine of theta is equal to these two values, but we want everything above that. So I'm going to highlight everything above that, start here and go up and around. This is what we want. These are the values that we want to express. Sorry, that became a parabola. Oh, computer. So we want these values that are, let's try it again, that are highlighted in green along the circle. And so we need to find a way to describe them in terms of theta. So what is theta here? Well, we can see theta kind of goes from here to here, right? If we're going to start with 0, we want 0. We want all of those values. We want from 0, so we want theta, that's not the pen I want. We want theta to be from 0 all the way up to, and we can include 0 all the way up to, but not including 7 pi over 6. So I'm going to get rid of that and put a 7 pi over 6 here. Let's do it. 7 pi over 6. But that only takes care of this part. So now we also need a little bit more. Another part of that solution is going to be this little bit here. And so we're going to also say that theta can also be 11 pi over 6, not including 11 pi over 6, but greater than 11 pi over 6. Theta can be all the way up to and including 2 pi. And, we could choose to not allow the 2 pi because the 2 pi is already kind of included with the 0, but I'm just going to allow it there. All right, so this is our solution. I don't know. The textbook put or here, and I want to know what you guys think. What about and? This and this is the solution. Because I look at this and this is not like a broken space, but I guess it is broken. So I guess the or makes sense. You know what I mean? It's broken because this is not a continuous space. If I talked about this as negative pi over 6 all the way up to 7 pi over 6, then it would make sense. But since these are almost like two disjointed sets, even though the visual is continuous, I don't know, deep thoughts. Let me know what you think about that and any other concerns you might have for the lesson today, guys. Thank you. Take care.